Alright, we're totally going to switch gears, and the last 3 sections that we're going to do all have to do with polynomials. So before we can define what a polynomial is, we need to know what a monomial is. Mono means one. So a monomial is one of something. It's a math expression including one or more of the following. So it can have numbers, it can have variables, it can have multiplication, and whole number exponents. So no fractions, no decimals. Monomials cannot contain addition or subtraction. You can't divide by a variable, and you can't have negative or non-whole exponents. So fractions and decimals. So we have some examples down here. Some are examples, some are non-examples. How about 5? Definitely a monomial. It has a number, one of those things. The next one, there's something wrong with it. It has a negative exponent. You are not allowed to have that. That's not a monomial. Plain old x. Totally okay. That's a monomial. Negative 7xy. You have some numbers. You have multiplication of x and y. So this is a monomial. And then the next one. This is technically a fraction, 1/2, but that's totally okay because it's just a number. It's not one of your exponents. And then it has multiplied by x to the 4th. So that also is a monomial. So we need to do something called finding the degree of a monomial. And the degree is basically the level of complexity, how complex it really is. And it's found by adding all the exponents together. What we're basically doing is finding the number of variables. And it doesn't matter if they are different variables. I just want to know how many variables something has. So for a, negative 2, a squared, b to the 4th. So negative 2 doesn't have any exponents on it, but a and b do. So the total number of variables that I have 2 a's, 4 more b's, that gives me 6. The degree of that monomial is 6. The next one, just plain old 4. There is no exponents on there, no variables, so we just say it has a degree of 0. For C, 8y, the 8 part, no degree on there, but the y, we have one of them, so this has a degree of 1. Be careful with the next one. Even though the only exponent we see is 5, remember that n has a 1 to it. And also remember, we're finding the number of variables. So we have 5 m's and 1 more n, and that will give us 6. So now that we know about monomials, let's talk about polynomials. Remember, poly means many. So a monomial, or a sum or difference of monomials, is called a polynomial. So remember, sum means that we can add things. Difference means that we can subtract things. Some polynomials are named based on the number of terms or the number of parts. And these names you need to memorize. A binomial, think bicycle, you have 2 wheels, is the sum or difference of 2 monomials. Only 2. So 2 examples are there. 2x plus 4. The 2x is one monomial. The 4 is another one. So this is a binomial, 2 terms. The next one looks a little messier, but we still just have 2 terms. This 35x, y to the 5th, and then negative 4, y squared. A trinomial, think tricycle, is the sum or difference of 3 monomials. So here we have 5m squared, 4a, and negative 12, 3 different terms. And then negative 13a, 15b, and 4 cubed, 3 different terms. So we know how to find the degree of a monomial, just one of them. But if we want the degree of a polynomial, the entire thing, the degree of a polynomial is based on its most complex term. Find the degrees of all of the monomials, and the greatest degree present is the degree of the whole thing. So here are 3 different terms, 11t cubed u squared, 34t squared u, and 5. So find the degree on all of them. first guy has a degree of 5. Next one has 2 t's and 1 u, so that's 3. And just plain old 5 has a degree of 0. So the highest degree here is 5. So that means the degree of this whole polynomial is 5. Try the next one on your own. So the next one's kind of strange. We have a tie for 3, but that's the most complex term. All of those have a degree of 3 except for 2xy, so that means the degree of the whole polynomial has to be 3. Writing polynomials. Normally in math class we have an order to things. So if I were to give you like 2 plus 3x, chances are most of you would write it as 3x plus 2. The other way is definitely not wrong. There's just an order to 3x plus 2. And this order is based on ascending or descending order of the exponents. So most of the time when you have more than one term in here, more than one variable, so we have x's and y's here, we pick one of them, either the x's or the y's, and we order it in some way. I'm going to pick the x's. You could definitely pick the y's. But if we pick the x's, and I want to order them from biggest x to smallest x, it would look like this one first, negative 11x to the 4th. And then the next amount of x's is that one. So plus x cubed y squared. And then the next lowest amount of x's is negative 4 x squared y. And then this guy only has 1x, so we want to write him next. And then finally negative 3 with no x's on there. Pause the video and see if you can write it in descending order with the number of y's. So this would be descending order with the number of y's as our focus. I will always tell you, or you will only have one variable to worry about. So this standard form happens when there's only one variable present. Not like the other ones, but when we only have x's or only have y's. Standard form says that your terms are arranged so that the exponents decrease from left to right. And then the very first term is pretty important. The coefficient, or the number on the first term, is called the leading coefficient. And when we get to graphing, that will have a lot to do with what the graph looks like. So if I want to write this in standard form for a, first of all, I notice there's only one variable here, so there's only one choice for me to do. So I'm going to look for the one with the most x's, and it's this, negative 7x to the 5th. And then let's write it in descending order. The next lowest amount of x's is 4x squared, and then 6x, and then finally plus 9. My leading coefficient in this case would be that negative 7. Not really too important now, but it will be. The next one in descending order would be y to the 6th plus y squared minus 3y. My leading coefficient here would be 1. So all polynomials have special names, and we can name them 2 different ways. We can name them based on their degree, and then based on the number of terms they have. Just like all students, I can categorize in gender and then what grade they're in. So 2 different ways to categorize them. Degree names. Hopefully some of these should be familiar. If it has a degree of 0, it is a constant, like the number 3. If it has a degree of 1, it's linear, like 3x, because if you were to graph that, it would make a line. A degree of 2 is quadratic, like 3x squared. Cubic would be 3x cubed, or to the 3rd power. Quartic is 3x to the 4th power. And then pentic is 3x to the 5th power. You need to have these memorized. And then we can also name things based on terms. Remember, a monomial just means one term. So, like x. Binomial means 2 terms. X plus 3. Trinomial means 3 terms. Like x plus y plus 3. And then after that, we run out of names. We just call it a 4-term polynomial or a 5-term polynomial, and so on. So let's name some things. First of all, we want to figure out what its degree is. So we always name that one first, and then we tell you how many terms we have. So remember, the degree of the polynomial is the highest degree that we have. So this first one has a degree of 3. The next one has a degree of 1. So the highest degree is 3. So this has a 3rd degree, or it is cubic. And then we count the number of terms. We have 1, 2. So this has to be a cubic binomial. The next one, the highest degree is 6. If you look, we run out of names based on degrees. So it's as simple as it sounds. It's a 6 degree. And then count the number of terms. We have 1, 2, 3, 4. And again, we ran out of names. So we call this a 6th degree 4-term polynomial. We're going to do section 7.6, the adding and subtracting, but I'm going to put it on the next video.